Hey everybody, this is Larry. This is day 6 of the August Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's farm. Yeah, as you can see, I'm back home. No more Doggo, no more Junos, sad face Larry. But you do get the rest of today's farm. N-ary tree level order traversal. I usually solve these live, so if it's a little bit slow, fast forward, whatever you need to do. Hopefully the mic is a little bit better as well right now. But anyway, okay, so given an N-ary tree, return the level order traversal of the tree. Okay. This should be pretty straightforward. Just look at the thing, the API definition of the node, and you just get the children. And you can do this in the way that I will think about it. Is just to do it. You can do it with breadth first search. You can do it depth first search. I think it doesn't really matter depending on how you end up. Yeah, I mean it's just implementation details. So definitely, if you feel like you're good with one, like if you're really confident with one, then practice the other, especially when you kind of think about the problem. Yeah, I mean, for this one, I'm going to play with breadth first search. It doesn't, it shouldn't matter that much. The node is n as you go to 10 to the 4th. The height is 1,000. The height is actually the thing that matters with the height is that if you're doing the recursion based one with the depth first search, you might have to think about your stack depth and stuff like that, which for certain languages, for certain constants, it may get you in trouble. But in this case, n is 1,000. I think is generally okay unless you're putting a lot of expensive stuff on the stack. So, but in either case, I'm going to do it with breadth first search, and with breadth first search we start with a queue, which in Python we actually have a deck because it's a double-sided queue essentially, where you can add and remove from the end, and then we just, this is we're gonna write this in a weird order, but we can add an enqueue with a node and a level, and then this is just maybe I didn't really need this actually, but yeah, okay, maybe I didn't. This is too whatever, but help. But in this case, let's start with root and 0. I mean, it's still probably helpful, to be frank, but yeah, it should be okay either way. Yeah, I mean, because you get some drive, which means do not repeat yourself, and you kind of remove duplicate code, right? So there's definitely some helpfulness there. Yeah, and then here while q is equal to 0, then node level is equal to q.pop left. So this is just standard breadth first search stuff. If level is greater than let's just say length of the answer, then answer.append an empty thing. Otherwise, we just then level is equal to the length. I'm just thinking about off by 1. I think it's because we start at level, we need, because level could be 0 in the beginning, right? So we want to make sure that, and then this just takes the last element and then append it to node.value, I believe. Yeah. So that gets the processing. That's the order traversal, and then of course we want to get the next. We want to look at this node's children. So yeah, for child in node.children, q.append child level +1, and this should be good. Maybe I have some off by 1s, but conceptually the idea should be good. And of course now I'm gonna write some magical. I didn't define it. That's a silly mistake, but that's okay. This is why you write tests, because this is pretty easy to fix. Does this look okay? Let's show the difference. This looks okay. So what is the only other thing that may change? The 0 case. I think the 0 case I might actually fail because this root is none, which is always a little bit awkward. So let's take a look. Yeah, so this is really weird, but yeah. And you don't have to do it here because you know that every child is not going to be a none. And then what's the another case? Maybe just one node, just for funsies. But I feel like we're a little bit better now. Okay, this looks good. Let's give it a submit. So this is accepted. So if you know breadth first search, you already know this is going to be linear time for complexity and space. But if you want to really, if you want to derive it from, just like being able to explain it to anyone else, for each node in the entire tree, we do push it into the queue once, and then we pop it off the queue once, right? So that means that, So that means that for every node we push and pop once, that means that it's going to be linear time because it takes constant of time for each operation amortized. Because this is all the pushing, which we amortize it to the node, and then all the popping, which is once per node. In terms of space, it's going to be linear time, hopefully for an obvious reason, which is that the size of the output is going to have one value for every node in the original tree. So yeah, linear time, linear space, breadth first search is the way that I did it. You can definitely do it in depth first search as well. And I think there's also there's actually, now that I think about it, there's another way that people implement it with a level order queue. So you kind of basically parse each level at a time with a queue. I didn't do it that way, and maybe I could have practiced that, but if you want to play around with it, that's fine. But I don't think it has that much. It comes up here and there randomly if you want to, but if you don't, it's fine. So I don't know if it's worth doing it, but maybe play around. Learning is just about exploration, so that's why I encourage. Anyway, that's all I have for this one. Happy Friday. Hope you have a great weekend. I'll see you soon. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.